Hello ladies and gentlemen, welcome to my video. First of all, I'm sorry that not able to upload new video in the last several days, has been busy with other projects. In future, I will try my best to upload at least 3 video in a week. This is today's question. It can be solved using Feynman integral tricks, which is differentiate inside the integral. First, define function j with parameter alpha and beta equals to integral 0 to infinity natural log x squared plus alpha squared divided by x squared plus beta squared dx, where alpha must be equal or bigger than 0 and beta must be bigger than 0. We can see that our question Q is equal to j when alpha equals to 3, beta equals to 2. Let's differentiate function j over d alpha, which is I call it j prime alpha beta, which is equals to integral 0 to infinity 1 over x squared plus beta squared differentiate of natural log x squared plus alpha squared over d alpha and then dx. From here we obtain j prime parameter alpha beta equals to integral 0 to infinity. Denominator is x squared plus beta squared multiply x squared plus alpha squared, while numerator is 2 alpha, of course dx. Here we perform partial fraction to the integrands. Since my channel is focused on the integration, I do not show how to do the partial fraction, but it can be done, just requires some minutes. Anyway, we can rewrite j prime alpha beta equals to 2 divided by beta square minus alpha square integral 0 to infinity. Part number 1 of the integrand is alpha divided by x squared plus beta square, while part number 2 is negative alpha divided by x squared plus beta square, of course dx, which is equals to 2 divided by beta square minus alpha square, and then multiplies inverse tangent of x over alpha minus alpha over beta inverse tangent of x over beta. Put in x tends to infinity and x equal to 0. We know inverse tangent infinity is pi over 2 and inverse tangent 0 equals to 0. From here we obtain 2 divided by beta square minus alpha square and then multiply pi over 2 minus pi alpha over beta. Further rewrite gives us 2 divided by beta plus alpha multiply beta minus alpha, and then multiply beta minus alpha divided by 2 beta. This is simplifiable. That gives us j prime alpha beta equals to pi divided by beta multiply beta plus alpha. From here we can perform integration such as j alpha beta equals to integral j prime alpha beta and then d alpha, which is equals to pi over beta integral 1 divided by beta plus alpha d alpha. Therefore, function j alpha beta equals to pi over beta and then multiply natural log beta plus alpha plus a constant c. Label it as equation 1. Remember there is another j alpha beta that we defined at the beginning of this video. It will help us to find the value of constant c. Label it as equation 2. We can set alpha equals to 0 and beta equals to 1. Therefore, equation 1 gives us j alpha beta equals to pi multiply natural log 1 plus constant c. Meanwhile, equation 2 gives us j alpha beta equals to integral 0 to infinity 2 natural log x divided by x squared plus beta squared dx, where beta is equals to 1. In one of my previous videos some weeks ago, we successfully derived and showed that integral 0 to infinity natural log x divided by x squared plus beta squared dx is equals to pi multiply natural log beta over 2 beta. In this case equal to 0 because beta for our case is equals to 1. Consider both cases, we can easily conclude that c equals to 0. Therefore, we have 2j. The first one is the one we defined at the beginning of this video, and the second one is the one we found just now through the derivations. We know that the answer of this question is equal to j when alpha equals to 3, beta equals to 2. Therefore, we are coming to the conclusion of this video. The final answer of this question is equals to pi over 2 multiply natural log phi. Thank you for watching this video until the end. Please continue support my channel, subscribe, give a like and share my video in your social media. See you soon for new video. Bye bye.